We're going to continue our discussion of counting. So let me begin with a simple question for you guys. My question is, how many unique ways can the letters in ABC be ordered? ABC.
6.
4 factorial.
9 times.
4 factorial.
6. 3 factorial.
No, wait, I thought you said.
I was right.
I thought you said A, B, C, D.
Yeah, just ABC.
I misheard you, so.
You would have been correct. Good. Okay, we can count them all. Let's count them all. ABC, ACB, BAC, BCA, CBA, Chinese Basketball Association, CAB.
Chinese Basketball Association? Is that a real thing? Yeah.
Obviously.
Is it in China or in India?
Okay, so there are 6 ways. And how can we count all those ways? Well, we can just pretend like we have 3 different buckets. And we have 3 choices for the first one. It could be A, B, or C. But once we've placed that one, we're only going to have 2 choices for the next one, right?
That's why I said 3 factorial.
Very good, Luna. Very good. Very good. Okay, so the answer is going to be 3 factorial.
C? Although I misheard. Although I thought you said A, B, C, D, so I said 4 factorial.
Okay, any questions about this? 3 factorial. Now let me change up the question a little bit. How many ways are there how many unique ways can you rearrange the letters in APP, app?
Ooh, unique ways.
Yes.
4. 3.
3, very good. Good guess.
No, I figured it out.
Okay.
Through logic and reasoning.
So we can list them all out, right? We either have APP or PAP or PPA. You guys remember the song PPAP? That was when I was your age. That was our song.
Wait,
What song?
Pen, pineapple, apple pen?
What?
Not like dead me.
Never mind. Okay, guys, why are there only 3 this time? That's because we're dealing with identical letters, which means that we have to deal with something called overcounting. Why are we overcounting? I'll make this quite clear. Suppose the P's were distinct. So let's say it was A, and then P1, and then P2. Okay, in this case, there would be, 3 factorial, 6, very good. The reason is because, right, we would have A, P1, P2, but we would also have P2, P1. And similarly, we would have P1A, P2, but that would also give us P2A, P1. And then P1, P2A, and P2, P1A. But as you can notice, if we make the P's identical, we're going to overcount by a factor of 2, because these are identical. These are not unique orderings if P's are identical. Okay, so that means the answer is actually going to be 3 factorial divided by 2 this time. So that's 3.
So overcounting.
Okay, so whenever we overcount, that means we have to divide by something, depending on how much we're overcounting every single unique ordering. Okay, so in this case, we're overcounting each ordering by 2, and so that means we have to do this thing.
Wait, so it's every repetition. So since there's 2 P's, then you do 2 over 2.
I don't understand what you just said. But
So there's 2 P's, it means you divide by 2?
Yeah, that's what I mean.
yeah, you're technically dividing by 2 factorial. And let me just explain why. Suppose now we have a really pen, pineapple, apple pen, APPP. Okay. Right? How many orderings are there now?
3.
4.
2, 1.
There are 4. You can count them all. Here's our pen, pineapple, apple pen, and then PPPA. There are 4, right? Why are there 4? It's actually 4 factorial divided by 3 factorial. Because if we were to count them, order them normally, if they were distinct, there would be 4 factorial, right? Because we have 4 letters. But every single one of these would be overcounted by a factor of 3 factorial. And why is that? That's because if the P's were distinct, like if we had P1, P2, P3, how many ways are there to order P1, P2, P3?
Factorial.
3 factorial.
Wait.
How many ways are there to order P1, P2, P3 within this ordering? There are 6, right? There are 3 factorial.
But the P's were the same that P. This is just one.
Yeah, so that's why we have to divide by 3 factorial.
So like number of so like
Because within this P1, P2, P3, it could have been P2, P1, P3. It could have been P3, P2, P1, etc. And there are 6 versions of those that we're overcounting by. And so that means we are overcounting by a factor of 3 factorial.
Alright, now do YOLO.
That one's too easy. Let me do a different one. Let me do this one.
4 factorial over 2.
Let's now do,
Wow.
guys, please, let's do AABB.
EBOLA.
Okay? Anybody want to offer a guess for how many unique ways for this one?
3 times
12, 4, 2,
2, 1.
factorial divided by 2.
7.
6.
6.
6. The answer is 4 factorial divided by 2 factorial times 2 factorial. Why is that? We can look at each individual ordering. Okay, so AABB. Okay, I'll just count them all just to prove that's 6. Okay, we have AABB, we have ABAB, we have ABBA, ABBA. I do like ABBA, yeah.
What's your favorite song?
I forgot the name. No.
Is it like this? So this?
Good.
Waterloo?
No, not Waterloo.
Take it all?
Yes, winner takes it all. It's a good one, yeah. Okay, so there are 6. Why are there 6? That's because for every single ordering, we're actually overcounting by a factor of 2 times 2. Why 2 times 2? We can look carefully. Let's say they were all distinct, A1, A2, B1, B2. That means for A1 and A2, there are 2 factorial ways to order A1 and A2 within this ordering. And then there are 2 factorial ways to order B1 and B2 within this ordering. And so in total, there are going to be 2 factorial times 2 factorial ways to order A1, A2, B1, B2 within the AABB scheme. And so the answer is 4 factorial over 2 factorial. Hopefully that made sense. Well, you guys can try 1, 2, and 3. 1 minute. Remember, don't simplify if it's less than 1,000.
Mr. Knight, for Facebook, would it be 8 factorial over 2 factorial?
Mm-hmm.
And then, for Christianity, there's like 3 I's, I think. Is it
3 I's and 2 T's.
3 I's and 2 T's? How would you do?
So
Oh, it
same
would be
concept
3
as here.
Okay, thank you.
Yeah. Over winter break, I'm gonna go find all my Facebook friends and eat lunch at their campus.
Wow, where are you eating lunch?
At Facebook. That's the point. It's free, right?
Wait, at what?
Yeah, it's great. Did you ask about Instagram? Yeah, I'm not following you back. I'm not accepting your follow request.
I didn't calculate it yet, but it went correct so far.
It's good. Yeah. I don't follow minors. I'm sorry. It's not appropriate. Yeah. So here we have 5 letters. So there are 5 factorial ways to order it.
Oh, so you just do like.
Yeah. Yeah, so that's equal to 120.
Oh, that's not what it does? And then you only do the things.
Only when they're identical letters.
Bro, this guy has been Chicago, bro. This guy has been You guys are awesome.
Is anybody absent? Anika.
You want to simplify it? If it's under 1,000.
Nico is also absent, right? Nico.
A as well.
Oh, Jaden as well. Didn't notice.
Wait, what's wait? Can I see it?
Wait, no, there's 3 eyes, 2
Did I get this correct? So for this, there's two T's and 3 I's. So like, would I do the 3 factorial, 2 factorial? Okay, so when there's 2 different ones that repeat, then I would do it factorial.
You divide both.
Thank you.
Guys, I got it.
Is this correct?
Yes.
And then for this one, would I leave it as 2 or 2 factorial?
Both are fine.
Both fine. And then I don't have. How would I know if it's above 1,000 if I haven't counted it yet?
You just have to know.
Just like kind of get it.
You have to kind of have your intuition.
Okay. So I
You
can
know, 7 factorial is above 1,000 because it's 5,000. 7 factorial is 5,040. So if there's a factorial above 7 without a super big factorial in the denominator, it's probably going to be above 1,000.
Okay, perfect. Okay, so this is good?
Yeah.
For number 3, do we like let's multiply this out or just?
Nope, that's fine. Guys, let's continue. Let's continue. Let's talk about number 4. I'm lecturing. So number 4, let's talk about combinations now. Can you guys be quiet, please? Liam, face the front. So let's say we had a class of, let's start with 5 students, okay? Alice, Betty, Charlie, David, and Eleanor. Okay? So how many ways would there be to choose 3 students to form a group from these 5 students? Let's try.
120.
Nobody's correct, so let me just
Factorial
talk.
divided by 3. 5 factorial divided by 3.
Is it 60?
How about we just stop guessing? How many ways are there to choose 3 students to form a group? So how many ways can we get a group of 3?
125.
Okay, let's just stop talking. It's not helping anybody. Okay, so let's try to form this group, okay? Let's form this group. How many choices do we have for the first student? We have 5 choices because we can choose either Alice or Betty or Charlie or David or Eleanor. But we're only going to have 4 choices for the next student, right? Because we can't choose that first student. It's already been chosen. And then we'll have 3 choices for the last student. However, that's not the answer because in a group of 3, the order does not matter. Okay? So the group that contains, Alice, Betty, David, that's the same group as Alice, David, Betty, right? But both of those would have been counted in this way of counting things. And so that means we're actually overcounting and we actually need to account for that somehow. So let's consider our group of Alice, Betty, and David. How much are we overcounting by? We're overcounting by 3 factorial because there are 3 factorial ways to order Alice, Betty, and David within their own group. And so therefore the answer is actually 5 times 4 times 3 divided by 3 times 2 times 1. But what does this remind us of? This reminds us of the binomial, isn't this? This is just 5 choose 3, right? So that's why the binomials are called, it's not 10, it is 10, sorry. Yeah, so it's 10, and
It's the combination.
that's why we call it a combination. That's why it's called it a binomial. That's why we say 5 choose 3. It's because it tells us the answer if we have 5 things and we want to choose 3 things out of them. If order doesn't matter. Yes. How would you calculate 5 choose 3? You would just write this.
I have a question.
Yes.
Could you explain again how you got 3 times 2 times 1?
It's 3 times 2 times 1 because there are 3 factorial ways to order every single ordering. So we are overcounting by 3 factorial.
Wait, but then how do you get the 5 times 3?
Let me see what that is.
Okay, let's do 4 and 5. Give you guys 1 minute.
Okay,
Why is this the case?
we're choosing, a group of 3 out of 5 students.
Yeah.
So for the first spot, we have 5 possible choices. Second spot, 4 possible choices.
yeah.
Third spot, 3 possible choices.
Okay.
But that would be overcounting because.
Would it just be like this?
The same as, yeah.
Yes, you need to simplify them because they're under 1,000.
So we have to.
Oh, okay. Just this one, right?
Both are under 1,000.
They're both.
Yeah.
Oh wait, right.
Yes.
It's an emergency.
Okay.
This is
Yep. It must be simplified.
15 choose 2.
Yep.
Oh, okay.
It's good. This must be simplified. 4 and 5. They're under 1,000.
Did I do it?
Good.
I got it. Let's go. I did it. You get it? You get it? Some funny stuff. 15 students.
15 times 14.
Oh wait, no.
But then you have, I'm pretty sure it's all.
Yeah,
How many
50 times
students?
7.
So we got 1,
Are these two correct?
Good.
Yeah.
Yo guys, what's 15 times 7?
Good. Simplify. You can go.
Wait, like this? I did.
Yeah. So calculate. Right. All right. Go ahead, Justin.
Wait, would it be this?
8 people goes
Yes.
All right, thank you.
out. A group of 8 people goes out to.
That's good. That's good.
And then wait. Oh, never mind.
Okay. Are we all done?
So the next one will be the teachers.
It's just 12 choose 4, 15 choose 2, right? So we just need to figure that out.
If they ask a question like this with different numbers, would like this and this be set as like 15 too? Like no matter the number, like this is on top and this is on the bottom, like the groups are on the bottom.
Yeah. So the number of people in the group is on the bottom. That's how much you're. That's how much you're choosing.
Oh wait, oh wait.
And then the one you're choosing out of is on the top.
Oh wait.
You don't need to even solve it.
Okay, let's continue to number 6.
Done.
Good. Let's do number 6, okay? I encouraged 1A to do it by themselves, but they seem to be very confused, so I'll help you guys. So we have a ballroom dance class with 8 boys and 8 girls. How many ways are there to pair everybody up? Obviously, ballroom dance, it's only boy-girl, right? So, how many ways are there to pair everybody up? And so I'm not asking about how many possible pairs are there. I'm asking about how many total ways are there to pair everybody up. Make sense? There's a difference.
64.
Nope, that's how many possible pairs. I'm asking about how many possible ways are there to pair everybody up. Meaning that, right, if I have like boy 1, girl 1, boy 2, girl 2, boy 3, girl 3, that's different from boy 1, girl 3, boy 2, girl 2, and boy 3, girl 1. So I'm asking about how many possible arrangements of these are there. That's quite a different question, isn't it? Okay, so there's some subtle overcounting in this question, so it's very interesting for our purposes. Let's try to set this question up, okay? Let's say we have, once again, we have our buckets. So let's say we have our boys here and our girls here. So we'll line them up like this. Dot, 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 dot. Okay? So this is our row of boys, and we have girls here. So let's say we're trying to choose our first boy in the boy-girl pair. How many choices we have? 8, very good. How many choices of the girl? 8, good. And then we'll have 7 choices for the next boy, right? And then 7 choices for the next girl. All the way down the line.
So 8 factorial squared.
All the way down to our last boy and our last girl, which we only have 1 choice for.
8 factorial squared.
Yep. So our answer, or so we think, is 8 factorial squared. But how much are we overcounting by? How much? How much are we overcounting by? What factor?
8 factorial.
Yes, 8 factorial. Why?
Because there's an 8 factorial factor that you're overcounting by.
Oh my god.
Anyways, we're over.
Let's go.
Please. We're overcounting by a factor of 8 factorial because there are 8 factorial ways to order the pairs once they've already been paired up, and those orderings are not unique. For example, you could have boy 1, and then girl. You could have boy 1, girl 1, and then boy 2, girl 2. But this is the same as boy 2, girl 2, boy 1, girl 1. So these are identical, but we're counting them twice in this way of doing things. And so how many ways are there to order those pairs? There are 8 factorial ways to order the pairs. And so the answer is 8 factorial squared divided by 8 factorial, which is 8 factorial.
Why? Why is it 8 factorial divided by 8 factorial? Why is it divided by 8 factorial?
We're overcounting by 8 factorial because there are 8 factorial ways to order the pairs. And those are actually, they're not unique orderings, right? So we need to divide by that. Let me do this in a different way, and I'll prove to you that we get the same exact answer. Let me do this in a different way. There's actually a way to count them without doing any overcounting at all. Can anybody think of that way?
Just do 8 factorial.
The way to do it is by lining up the boys and then pairing the girls to them once they've already been lined up. Okay? So we line up the boys first. That way we know there won't be any overcounting because they're all lined up specifically. And then we pair the girls to them. And we have 8 choices, 6 choices, 7, 6, 5, all the way down to 1. And so this gives us 8 factorial. And now we know that there's no overcounting because the boys have already been ordered. So any different ordering of girls produces a different ordering. Liam.
Can you do it both ways?
Yeah, the girls could be lined up too. That's
Or
fine.
no, I meant like both ways, like as in. No, I mean like both ways, as in like both you got both solutions.
Wait, bro.
Like the same solution.
Yeah, they give us the same answer because they're both correct.
So could you just do that?
Yeah, that's what I showed you guys. Any other questions?
Eight factorial.
40320.
40,000?
Yep. Okay, let me also do question 7 because 1A apparently could not do this by themselves, even though I thought they could. Okay, let me do question 7, except just with 4 people, just so it's easier to draw. Okay, so let's say a group of 4 people goes out to a Chinese restaurant. They sit at a circular table. How many ways can they arrange themselves if arrangements separated by rotation are considered to be identical? You guys know what this means, right? What I'm saying is that A, B, C, D is the same as D, A, B, C. Because these are separated by rotation, they're not distinct orderings.
Well, technically.
Okay? So,
Well, technically, the
question for you
number is
guys.
infinite because if assuming there's one long continuous sofa-ish seat, they could sit at theoretically any infinite simple angle. So the combination.
Theoretically, but that is not what we're considering.
I know.
Okay, so what is the answer?
4.
6.
What I'm asking is,
7.
how many total arrangements are there accounting for this overcounting? The answer is 6, actually, yes.
7.
The reason is because that is 4 factorial divided by 4. Okay? That is because we have 4 ways, we have 4 factorial ways to order them normally, right? 4, 3, 2, 1. But we're actually overcounting by a factor of 4. Why is it a factor of 4? Because there are 4 different ways to rotate them, right? A could be here, A could be here, A could be here, or A could be here. And we could rotate them in 4 different ways for every single unique ordering. So that's why we're overcounting by 4. So we must divide by 4. And our answer is 3 factorial.
Factorial is number of unique orders, and 8 is number of ways to rotate. The number
Yes.
of unique orders.
So the answer is going to be 7 factorial for number 7.
I know. So 8 factorial is number of unique orders, and divided by 8, which is the number of ways to rotate.
All right, let me have you guys try number 8 and 9 by yourself. We'll see how this goes.
How'd you get?
It's because 4 factorial divided by 4. It's then you cross out both 4s and you touch 3 times 2 times 1 on the top.
You're right.
And then that's philosopher.
Like me, basically. Like me, basically.
Okay. Yes?
You already did it, right?
I did.
So do we just write 8 factorial?
Do you know how to do it?
Factorial times 2.
Sure.
2 times 3. It is. 20 factorial.
Bro, Benjamin.
Is that right? 2 times 20 factorial. Okay. Okay, this is harder.
Come on, this is actually the most traumatizing thing I've ever seen. I have passed Chem off.
Other teams. So
Doctor said.
Is this correct?
No.
What's wrong with it?
Think about a game, right? This is soccer, so there are 2 teams per game. Okay. So if we were trying to set up a game, we have to choose the first team, right? And then we have to choose the second team. And then we have to think about how much we're overcounting by. Okay?
I
Try to think about it.
Is it this?
Nope. I'm not sure where the factorial is coming from. Try to set up a game, right? The game has 2 teams. So how many possible games can you set up?
40?
overtime by 40.
You have to, right? Think about the buckets. How many teams you can choose for the first?
Oh, 20 times 19.
Right, and then how much are you overcounting by?
20?
Huh?
Are you overcounting by 20?
You're overcounting by 2.
Oh.
Because A versus B is the same game as B versus A.
Oh, okay. So 20 times 19 over 2.
Yep, and then you have to multiply back the 2 because they play each other twice.
Okay. They're playing twice, so like this, right? And they're playing them.
No, it's not 20 factorial. You can't just throw factorials around, right? You have to think about what's happening.
Yeah, so like, what do you do?
Wait, why is it not 20 factorial?
Like, why would it be 20 factorial?
Because like, so if you choose one team and then they play 20 games, so then that's 20 factorial, and then
But like, where's this factorial coming from? You can't just say factorial.
That's because after
they play 20 different teams. So it's like,
Yeah, each team plays 19 different teams, okay? And there's no factorial involved.
no.
Okay, clearly I have to explain this. So let me talk about question 8 as well. Okay. Okay, so how do we count games? We count games by setting up the games, okay? This is an idea called constructive counting, okay? This is what we're doing. We're trying to construct what we're trying to count. That's how you count things, okay? So how do you construct a game? You choose 2 teams. So it's 20 choose 2. Does this not make sense?
So you're right.
Right? Games is nothing different from us choosing 2 teams from a group of 20. So the number of games is 20 choose 2 because we're choosing 2 teams to play a game from 20 teams. So the number of games is 20 choose 2 times 2 because they play each other twice.
Is that overcounting?
We accounted for the overcounting already. in 20 choose 2?
Wait, is it 20 factorial times 3?
Oh my gosh, you were right.
Wait, 20 times 2.
Okay.
Wait, I don't get it. Bro.
Okay, I've taught you guys everything you need to know. The rest is just about your own thinking, whether you're able to translate problems into what you've seen before.
How'd you get 20? I'm just gonna ask to make it
Yeah.
clear for me. How do you get 22? How do you get 22?
Because we're choosing 2 teams, because the game is 2 teams playing each other, right?
Yeah.
It's just
And then
380,
two is,
right?
Yeah.
Wait, is this 80? So,
No.
am I close?
Think about first how many games are in each group, and then multiply that by 8.
Yeah, that's what I did.
So how many games are in each group? Each
Oh,
group has
wait.
4 teams.
Oh, there should be 12, right?
No.
12 times 8. Wait, because I thought like, do I draw this out, or is this like, or is there like a faster way?
Like within each group, you have 4 teams that are playing each other.
And then they play, all the teams play.
So there are
every
4
other team 2 times.
Yes. Oh, yeah, sorry, it is 12. I didn't see that play each other. So it's 4 choose 2 times 2. Yeah, so it's 12. That's good.
Oh,
And 12 times 8.
Oh, yeah. I think I messed the calculation.
Okay, let me explain it in a different way if it's not clear. In a game, we're choosing 2 teams to compete against each other. So it's something versus something.
380 ways.
Yes, very good. We have 20 choices for the first team, and then we have 19 choices for the second team. However, we're overcounting by 2 because A versus B is the same exact game as B versus A. And so it's 20 times 19 divided by 2, which is 20 choose 2. And then we have to multiply back the 2 because they each play each other twice. So that's 380. It's 380, yeah.
We did that.
Number 8.
Because if each team plays each other twice, then A versus B and B versus A is
So there's technically no.
Yeah, theoretically, you could say something like that. Like you could specify, oh, this is my home team versus my away team. Then they're not distinct anymore. Then the ordering doesn't matter. The ordering does matter, right? So then that way you wouldn't be overcounting. But in that case, you have to make sure you're not multiplying by 2, right? Yeah. Okay. I'll just explain 9 too, I guess. Just talk to all of them at this point. Okay, what is it?
Is it 144?
No.
96?
It's okay, don't worry. Huh?
96?
Yeah, 96.
Dang it.
Okay, that's because you just count the number of games within each group stage, and then you multiply by the number of groups, right?
That's what I did.
So every group has 4 teams, and they play each other twice. So it's the same question, right? It's going to be 4 choose 2 times 2, and that's the number of games per group. So you multiply by the number of groups, which gives you 96. Great.
Wait, where the heck go?
12 games per group and 8 groups. So it's 12 times 8.
Dang it.
Okay. You guys want to try number 10? I didn't do that in 1A, so we can do it for fun. We have time today.
Wait, times 8 groups. Wait, what? Wait, can I take a look at yours?
Number 10 is quite difficult. No, wrong. Number 10 is pretty difficult. Number 10 is pretty difficult because this one's a little challenging. So let's put in our buckets. We have 8 groups, right? Dot, dot, dot. Okay, so this is group A. Or, no, the order of the groups does not matter. Okay, so I can't label a group A, right? Let's say we have our first group. How many ways are there to choose our first group, which has 4 teams, right? 32 choose 4. Because we're choosing 4 teams from 32 teams. So the first bucket is going to have 32 choose 4 ways. Agree?
Yes.
How many ways are there to choose the second group?
Dang it. times 4.
Yeah, 28, choose 4. Because now we only have 28 teams left, and we're trying to choose 4 from that one. Next bucket, 24, choose 4. 20, choose 4. Dot, 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 all the way down to 4, choose 4, which is 1. Because once we have 4 teams left, there's only one way to put them in the group. Are we overcounting?
No.
We are overcounting because
Sorry about disrupting.
Yo. Bro, cracked up fracture, bro. Hey, he lost his character, bro.
anyways.
Yo, he lost character. Yo, this is like the first time he's gonna actually laugh this hard. We better have this video.
Anyways, we're overcounting by a factor of 8 factorial, okay?
Wait, I got it.
We're overcounting by 8 factorial because the order of the groups doesn't matter.
Is it multiplied by 8 or
It's divided by 8 factorial.
Dang it, I got it. I'm so close.
Because, right, the order of the groups doesn't matter. So if the groups were ordered in different ways, but with the same teams, then it's the same exact group ordering. So we have to divide by 8 factorial because there are 8 factorial ways to order the groups. So this is the answer. It's quite large.
And then you multiply the whole thing by 8 factorial.
Is he?
What?
No, simplify. Yeah.
Yo, that's when we talk about core memory.
All right.
Oh, can you help me?
Number 9?
Yeah.
That's good. So you're going to have 12 games per group. And you have 8 groups. So it's just going to be 12 times 8. Okay, guys, let's continue on to the card problems, which are very fun.
It's not that I'm not paying attention. It's
I
just
know.
like these are
Good.
genuinely confusing.
That is right. You're doing good.
It's like I can't quite visualize how this works.
I know, yeah. Let's do question 11. And I'm not going to do all of them. So 11A. Guys, be quiet. How many 3-card hands have all cards with the same suit? So these questions all have the same exact concept because it's just the same thing. We're just accounting for overcounting. So we're going to have a 3-card hand. Let's not think about overcounting yet. How many choices do we have for the first card?
52.
52. Very good.
And then 51.
Okay.
50.
Now we're interested in only those 3-card hands with all cards having the same suit. So if we want them all to have the same suit, how many choices do we have for the second card?
12.
12.
Very good. 12.
Groups of 4.
The reason is because once we've chosen the first card, the suit has been set, right? Let's say we chose an ace of spades. That means we only want spades for the rest of the cards. So that means we only have 12 choices for the next card because one of the spades has already been taken, right? And then we have 11 for the third card. Are we overcounting? The answer is yes. We're overcounting by 3 factorial. Right? Because ace of spades, 2 of spades, 3 of spades, that's the same as 3 of spades, 2 of spades, ace of spades. So we're overcounting by 3 factorial. So the answer is 52 times 12 times 11 divided by 3 factorial. What?
Where's the 11 come from?
It's 13 minus 2. Because we're trying to choose the same suit, but 2 have already been taken from that suit.
So you're choosing the first one, you don't know where you're getting it. Once you choose the first one, say you get ace of spades.
The whole, there's 13.
Wait, Mr. Nye,
Yes?
can you explain how like the 50, how you
Oh, I already thought of that. I thought it was
And now it's down to 12.
So I can choose any card for the first one because I don't have a suit set yet. So 52 cards for the first one. But once I've chosen that one, I'm only going to want cards with the same suit because I want to make sure they all have the same suit.
1,141 4 combinations.
So suppose I've chosen a spade, right? That means I only want another spade for the second card. So I have 12 choices for the spades. Because I have 13 spades total and I've already chosen one.
And then 11 just the
Yep.
one.
Mm-hmm.
Okay.
Let me do another one.
Well, actually, all 3 card hands are 3 of a kind because within one set of cards,
So,
you don't have any to
11 B and C are pretty simple. I'll let you guys do them yourself. 11D is quite challenging, so let me explain it. You guys know what a 2 pair is, right?
Yes.
A 2 pair is, for example, ace, ace, jack, jack. However, ace, 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 ace is not a 2 pair because it's a 4 of a kind. Okay? So just to clarify that. So a 2 pair requires us to have 2 distinct pairs within our 4 card hand. So let's try to figure out how to do this. To make this question a little easier for myself, I'm going to stipulate, okay, I'm making a stipulation that I would like my card to be ordered such that I have the pairs like this. So that my first pair is here, and my second pair is on the last 2 cards. Okay? Otherwise, it's more challenging. Okay, so how many choices do I have for the first? Good.
First, like 52 seconds.
Very good.
3.
Very good. I'm only going to have 3 choices for the next card because my rank has been set by the first card, correct?
Yes.
If I chose a jack, I'm only going to want to choose another jack for my next card. So I have 3 choices left for that jack.
Now we have
How many choices do I have for the third card?
50.
48. Because I want a distinct rank. If I chose a jack for the first pair, I don't want to choose another jack. So I only have 48 choices for the next one. It's 52 minus 4 jacks. And then how many choices for the fourth card? 3. Because I'm going to have 3 left from that rank. Like suppose I chose a jack for the first one and I got a queen on the third card. I'm only going to want one of the other queens for my last card.
I think we're overcounting by, is it like
3 factorial.
2 by 2 factorial squared?
You would think so, right?
3 factorial.
You're actually overcounting by 8, 2 cubed. Why is that? That's because we're overcounting in a very unique way. We're overcounting within the first pair, because that could have been, jack of spades, jack of clubs, or jack of clubs, jack of spades, but those are not distinct hands, right? So we're overcounting by 2 within the first pair. We're also overcounting by 2 in the second pair. But what else are we also overcounting? We're overcounting the order of the pairs. Because jack, jack, queen, queen is the same as queen, queen, jack, jack. So we have to divide by 8. Right? It's like it all makes sense, but you just have to know it.
Explain that one more time.
Okay, sure. You're overcounting within the first pair because the first pair could be, jack spades or jack clubs, but it could also have been jack clubs, jack spades, and those are not distinct. We're overcounting in the same way for the second pair, but we're also overcounting the order of the pairs themselves because jack, jack, queen, queen is the same as queen, queen, jack, jack. Ayla. 3 of a kind means they're the same rank. So like 2, 2, 2 or 5, 5, 5. Yeah.
I am praying.
Let's be on the test.
The easy ones from this classwork would be, yeah.
What about these?
Let's do, yep.
Is this one right?
3 of a kind, yes. Let's do question G. G is very fun. Guys, let me do question G and then you guys will have some time. Okay, now we're looking for 4 card hands where each card has a different rank and a different suit. So they have to be different numbers and different suits. Let's set up our question, okay? This one is very fun. Well, it's not hard, it's just kind of interesting. So how many choices do we have for the first card? 52. How many choices do we have for the second card?
13? No.
Oh, 51.
No. It's 52 minus
36, why?
12 times 3?
Yeah. Very good. That's because we have 12 ranks to choose from and 3 suits to choose from. Because we can't have the same rank or the same suit as the first card. So there are 36 choices for the second card.
And then 22.
Very good. We're going to have 11 rings to choose from for the third card and only 2 suits left.
And then 10.
Nope. Oh, sorry, not 11. 22.
And then 10.
Last one, we only...
10.
Oh, yeah, 10, sorry. I was going to say 1, but it's 10. Sorry. Good.
I think we're gonna teach a class now.
Yeah, I know, right? Okay, are we overcounting?
Yes.
Very good. Overcounting by 4 factorial. Thankfully, not that hard. So the answer is 52 times 36 times 22 times 10 divided by 4 factorial. That's quite fascinating. You know, what's interesting is that even though we have these fractions, we're always going to get a whole number. So,
I'm so keen into this. I love counting.
yeah, these are some of my favorite questions.
Oh my god, multiple choice. Hashtag less.
These are not multiple choice. Question 12 is just for fun if you guys have time.
I don't want to be preyed on. I don't want to be preyed on.
Okay, I'll talk about question 12 at 12:43 once we have 2 minutes left.
See,
It equals what? 10,000, 17,160.
Yes. You can also think about it differently. For C, the answer is just going to be 13. Because there are 13 form kinds, right?
yeah. Oh.
Are all these correct so far?
Yeah.
How about on the back?
Aren't those the ones that I did?
Did you check your work?
If you copied it right, then you're correct.
Also, would you wear this shirt?
Daniel, come back here. I need you.
But it was a long.
Liam needs you. Liam needs you.
Actually, no, you can go back to this nine. Oh, that, no, come here, no.
What is one suit?
Which one?
What is one suit?
1 suit. So club, diamond, heart, spade. So that means I'm looking for cards where these have the same suit, and this is a different suit. Yeah.
Can I go use the restroom?
Sure. What?
You're finding the same rank, right? All the same rank.
Yeah.
For E is this.
So yes, it is.
The numerator is correct, but the denominator is not.
Would it be 3 factorial because you're overcounting?
That's correct. Because you specifically actually implicitly added the stipulation that these 3 cards are the ones with the same suit.
Yeah.
So actually you're only overcounting by 3 factorial within this one, right? Because the order actually, you're kind of already setting the order kind of,
Yeah.
right? So it's not going to be 4 factorial.
Okay.
Did I set this one up right?
E?
Yeah, like the top part.
There's 13 ranks, right?
The last number is wrong.
The last number?
Yeah, because we're looking at a different suit, right?
Oh,
There would
different
only be
suit?
39 of us.
Or of each rank.
Right? 1 suit.
Oh, I thought it was a different card, so. And then, how do I know what to, how do I know, like, to find what I'm overcounting for?
Have to think about it. It's different every time.
Can you see if B, C, and E are right?
E is wrong because you're not overcounting by 4 factorial.
Okay.
I think these are
Correct?
right, I think.
I think or I know?
Huh? I think so, yeah, B and C.
Like, I don't understand.
Okay? Like, what about it?
Like, I don't really get like your process, how you did it.
The idea is we're trying to construct the hand first, so doing the same thing as what we were doing last class, except now we have to account for overcounting. So the final step we have to divide by something. But do you understand like the beginning part? Setting up the hand?
Like, I get you have the 52.
Yeah.
But like, I don't know how you get like 36.
Okay, well maybe the first question, do that first. Do you get the 12? 12, 11? If we have 52 choices for the first card, we only have 12 choices for the next one. Because once we've chosen a specific suit for this card, we only want that suit for the next one.
So there's 12 cards.
Right, there are 13 cards per suit, and we've already chosen one of them, so there are going to be 12 left.
Now the 4
Try to figure it out. This is 8, not 8 factorial.
Okay, so then this is also 8.
That one's not 8. Or yeah, sorry, yes, that one's 8. This one,
I just simplified it.
you're not overcounting by 4 factorial. You're actually only overcounting by 3 factorial. Because when you're setting up the question like this, you're actually implying that these 3 cards are the ones with the same suits.
Yeah.
So you're actually only going to be overcounting within these 3 cards. Because this one is always distinct.
Okay.
Yeah.
Thank you. Okay, and then other than that, everything's right?
For ease of 3 factorial.
You're overcounting by 3 factorial. Yeah.
Are these correct?
Good. 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 Here you're overcounting by 3 factorial.
Why 3 factorial?
You're only overcounting within the ones with the same suit.
I see.
Because this one is always a distinct suit.
All right. What are these?
This one is the exact same as D, except now.
Oh.
Okay.
I messed up on the denominator, but is this part right?
Yes.
Yeah, alright. So this would just be 2 to...
Yeah, it's also 8, because it's the same exact concept for overcounting.
Alright, thank you.
Which one? F? F is the same as D, except now it's suits.
Well, what? So, what does it require for, right?
So now you're looking for something like spade, spade, diamond, diamond.
And
Not 2, 2, 3, 3, for example.
so the number does not matter? Like,
The number does matter, but these numbers are going to change, because now
I mean
we're
the
looking
number
at
on the card. The ranks.
Yeah, the number on the card doesn't matter at all.
Why not?
This is not 8 factorial. It's 8. Yeah. It's 2 times 2 times 2. Same as this one. 2 times 2 times 2.
So that one would be 8 too.
It's the same concept as D, right? We're counting in the same way.
Is E 2000
If you're multiplying right, then yeah. I didn't multiply myself because it's greater than 1,000.
Oh, so but it's just 52 times 30.
Uh-huh.
Why do you have a bracket? 3. How many?
What? I'll talk about it. So yeah.
Wait, so this would be right.
Mhm.
And then you check in before?
I went through every question there, so you guys should all have it right. Yep.
I was just curious, when will you have my test period by?
Sometime. I'm kind of waiting for everybody to finish the makeups and grade all the makeups together.
Oh, okay.
Yeah.
How do you get 8 for the denominator here?
Same exact thing as here. Because now it's a 2 pair with suits, basically, right?
Oh, yeah.
Same concept.
I like copied what
12 do you have to do? Or?
I will talk about it right now. So.
I like copy.
Huh?
I like copy what you got, but like I don't even know if that's like the full answer, and I don't really get the concept.
Type. You can review it later.
Is 12 required?
Like, I'm gonna talk about how to do it and give you the answer. So, yep.
These three are overcounting. We say there's like ace of spades and three of spades, five of spades. Those you can, yeah. So those, it doesn't matter which way.
Right, good.
It's like by itself.
It's not 8 factorial. Right, I talked about it. It's 8. It's okay. Don't worry about it. Let's talk about question 12, and then I'll let you guys turn it in afterwards.
Wait, can you check this out?
The front side? I did every question, right?
Or the back?
Yeah, that's fine. Okay, I need to talk about question 12.
All correct?
I think so, yeah. Let's talk about question 12. Guys, be quiet, please. We're having a rock, paper, scissors competition. Hello, please sit down and have a seat. This is a question that is very interesting. So we're having a rock, paper, scissors competition, and students are matching up to play one round of rock, paper, scissors. Okay, so everybody gets a pairs up, and then if you lose your match, you're out forever. And if you win, you have to find another winner to play against them until there's only one winner left. You guys have done this before, right? So, how many games are there if the class has 3 people? Any ideas? 2, very good. Right, let's say we had Alice, Betty, and Charles. Did I say something different? Okay, how many games are there? Well, Alice and Betty can pair up first, so they can play. And then the winner will play Charles, and that's it, right? We will have our final winner. So there are 2 games. Okay, how many?
The possibility if B wins.
How many games? Okay, it's also 2, right? B would play C. That's it. Okay, how many games are there if the class has 5 people?
4.
Good. You can count them all, right? A, B, C, D, E. A and B could pair up, Alice and Betty. And then Charlie and David could pair up. And then let's say Alice wins and David wins. That means they would play each other. And then let's say Alice wins again. Then Alice would play with Ethan. And that would be 4 games and we would have a winner. Okay?
99 games.
Yes, very good. Why 99 though?
I saw the pattern, -1.
Yes, but why?
Because between the 100 people, and then you have
Okay?
first
This is a general rule.
First you have 50 games, and then of course 25 games.
There's more. It's a more subtle reasoning than that. Sorry. Anytime we have n teams or n players, and if they're playing single elimination, there are always going to be n-1 games. So for example, March Madness is single elimination, right? 32 teams. There are always going to be 31 games. So why is it 31? Why is it always n-1? No matter what kind of single elimination is, no matter what kind of bracket you form, it's always going to be n-1 games. And you have to think about why.
Can you check this, please?
It's fine, I'm not checking it.
Can I keep it then?
Yeah.
Okay, thank you.
All right, I'll tell you guys the reason why it's n-1. Unless you guys don't want to know, which is fine too. Nobody wants to know why?
I want to know why.
Okay, I'll tell you guys why.
So I don't forget.
I will tell you guys why. Every game has one loser. Correct?
Yes.
Each person loses only once. Agreed? How many people lose? All but one of the persons lose. Right? So that's why they're n-1 games, because they're n-1 losers.
So of course
each person, one person loses per game. One person loses per game, and yeah. So,